Inverting amplifier.
So what we did before was non-inverting amplifier, okay, the normal amplifiers. So in this time we have inverting amplifiers. So they are different. Okay? So the normal amplifiers, the first difference will be the gain. Okay? In a normal amplifier, the gain will be a positive number. However, in an inverting amplifier, the gain is a minus number. And the diagram, the graph of an inverting amplifier looks like this. Okay? As you can see, the gradient in this case is a negative in the negative direction. Okay? That's why we have a negative gradient, we have a negative gain. And the rest is the same. Okay? But how does this apply? Let me show you an example. Okay, now let me have an input signal. Say if I have an input standard AC signal of amplitude of 2 volts. Okay, then let's find out the output. Now the gain is minus 10. So if I'm doing the output, let's sketch a diagram. Okay, let's sketch a diagram. We have in, we have out. Okay, so when when the input is 0, okay, the output 0 times minus 10, they must be 0, they must be the same. Okay. However, when the input is 2 volt, okay, let's look at the graph. When the input is 2 volt, okay, 2 times minus 10 will be minus 20 volt. Okay, it will be a minus value. Now, actually, let's do this the way around. So if I have 2 volt, it will be minus 20 volt. Again, if I have minus 2 volt with the minimum input value, okay, input voltage, then the output minus 2 times minus 10, okay, minus 2 is here, it goes up, it's going to be positive, it's going to be 20 volt. So if I'm going to sketch the output of this diagram, I'm going to have a peak of 20 and minus 20 volts. Okay. Now it starts from the 0, okay, and when the input is 2, the output is minus 20 volt. Okay. When the input is minus 2 volt, the output is going to be positive 20 volt. So if I do sketch the diagram, the signal for output, we can, well, what we can say is, basically what we can say is, the amplitude of the signal has been amplified, okay, with a factor of 10, but it's in the opposite direction. Okay. So let's make it an inverting amplifier. Means it's like the whole graph has been reflected on the x-axis, then dilated, okay, vertically up. So that's what an inverting amplifier do. Is what's happening is it reflects the input signal first, then magnifies it. Okay, so yep, this is an inverting amplifier. Just the important thing, okay, always remember, okay, if the gain of an amplifier is a negative number, it is an inverting amplifier. It means it reflects the signal on the x-axis. Let's undo the magnification. Now let's look at a few examples. Okay. So example 1, question 1, I have a student, it increase the input voltage to an amplifier by this much. Okay. So the, the change in input is 0.3 volt. Then the output voltage decreases. So the change in output is minus 4.2 volt. So what's the gain of the amplifier? Just remember the gain is always the gradient. Okay? So if you do math, you know that the gradient is, well, the gradient is basically change in y divided by change in x. Okay? In this case, the gain is basically the change in output divided by the change in input. You do the math, the gain will be a minus number. I think it's going to be 14. Yep. Okay. Now let's look at the next question. Okay. Now let me enlarge it. Okay. We have an amplifier that has a voltage gain of 50. Then the output is an AC signal. Okay. The output is this much. What's the input signal? Okay. So if the gain is 50, okay, the output is 12 volt. Okay. So the input, we need to find the input. Okay. So the idea in this is the input magnified 50 times gave me 12 volt. So to find the input, it must be 12 divided by 50. Okay. Then it's going to be 0.6 volt. No, sorry, 0.2. 4 volt. Yep. Okay. Or you can just remember it like the output equals to the gain times input. Okay. So if I want to find the input, it must be the output divided by the gain. Okay. Now, next question. An amplifier has a linear voltage gain of 150. The input is an AC signal, okay, with a peak of 80 millivolts. Okay. So the input peak is going to be 0.08 volt. So what's the peak voltage of the output? Okay. So again, the input times the gain will be the output. The output peak must be 0.08 times 150. Do your math, do some calculation, you get something. Okay. Okay, now let's have a look at this question. Well, the gradient is negative, so it's going to be a inverting amplifier. And the question asks me, what's the linear input range? Okay, we talk about the input range. Okay, so in this amplifier is designed, okay, for input, okay, input range designed for input from minus 0.2 volt to positive 0.2 volt. Okay, so values other than that doesn't have the gain. Okay. Now the next question, yep. So the same amplifier, what's the maximum output voltage? Okay. The maximum output if you read the graph, it doesn't matter what's the input, the maximum output is going to be 3 volt. Okay, so this means, so if the input is minus 0.2 volt, the output is going to be 3 volt. If the input, if the output, if the input is something like minus 100 volt, okay, perhaps, well, the output is going still to be 3 volt. Okay. Yep. Now, let's look at the last question. Now, the amplifier, we have an amplifier, and we need to find the voltage gain. We need to find the gain for this region, for the, yep. So the gain is going to be the gradient. Okay. Now, just remember, when it's going up, the gradient is positive. We learned that in math, when it goes down, it's negative. Okay. So by guessing, well, by looking at the shape, I know the gain must be a negative, and then I calculate it. It rises 9 over, remember the unit, millivolts, over 30 millivolts, so 0.03. You do the math, it's going to be minus 300. Just remember the minus sign is important.